That rock here with Simpson math. Let's label some points on the unit circle that correspond to multiples of 45-degree standard position angles. Okay, so I'm going to draw over here a unit circle. So we have the unit circle here. The equation for the unit circle is x squared plus y squared equals 1. We know it's a unit circle. By unit circle, we mean the radius is 1 unit. So we know it's a unit circle because from the center out to the edge of the circle is 1 unit. So this point here must be 1, 0. So going up to this point on the circle would be 0, 1. But what we want to do is find points like these that are on the unit circle that correspond to standard position angles that are multiples of 45 degrees. Like for instance, 3 times 45 is 135. So 135 degrees is a multiple of 45 degrees. Let's draw a standard position angle that's 135 degrees. So I'll do it in yellow or gold, whatever this color is. So here's the standard position angle. There's the initial side. The vertex is at the origin. Now you picture it rotating and it terminates somewhere. So the other side's called the terminal side. So I'm going to rotate 45, another 45 gets me at 90, and I'm going to go another 45 degrees. Now I know that a 45 degree cuts across a diagonal, so if I have grid paper like this, I know to connect these points here, so I know to draw it like so. So that is 135 degrees, which is a multiple of 45. Now, from this point where the standard position angle intersects the unit circle, I can draw let's do it in green, I can draw a perpendicular. And that gives me a little reference triangle right here that is a right triangle because I dropped a perpendicular, so that's a right angle. And since this was 135, this must be 45 because 45 plus 135 will get me to 180. So that must be a 45 degree angle. If that's a 45 degree angle, then this must be a 45 degree angle. So the base angles are equal, which means that this distance right here and this distance right here, this little leg of the triangle and this little leg of the triangle are also equal. They're the same. So it's an isosceles right triangle. So we can use the rule that's called the isosceles right triangle rule, also called the 45-45-90 rule. That says that the hypotenuse, the square roots of 2 times larger than each of the legs, and each leg is square roots of 2 times smaller than the hypotenuse. And our hypotenuse here is the radius of the circle because it goes from the center out to the edge of the circle. Well, the radius is 1. So this hypotenuse here is 1 unit. And the legs in a 45-45-90 are always square roots of 2 times smaller than the hypotenuse. So I'm going to take 1 and divide it by the square root of 2 in order to get the length of these legs. So this leg here is 1 divided by the square root of 2. And this leg here is the same distance, so it's also 1 over the square root of 2. So if I was going to label this point here, then maybe I should go back to gold. Oh well, we'll just do it in green. I would go to the left 1 over the square root of 2, and I would go up 1 over the square root of 2. Now, your teacher probably wants you to rationalize these values, okay? Yeah, we got it there. Can we see it in the screen? Yeah, okay. Your teacher probably wants you to rationalize those values. I'm not so big on rationalizing. We rationalize because this is kind of hard to approximate, like what is 1 divided by the square root of 2? But if you rationalize, it's very easy to approximate in your head. Nowadays with calculators, I'm not sure why we're still doing it, but we still do. Your teacher's probably going to want this. So how do you rationalize? If you're rationalizing the value 1 over the square root of 2, you want a rational number down here. Well, if I multiply the denominator by the square root of 2, I get the square root of 2 times the square root of 2, which will be the square root of 4, which is 2. Nice rational number. Okay. But if I multiply the bottom by something, I have to multiply the top by the same thing, or I'm changing the value, right? So I multiply by the square root of 2 at the top. Square root of 2 times 1 is square root of 2. And so I have the square root of 2 over 2. And so this coordinate here is equivalent to negative square root of 2 over 2, comma, square root of 2 over 2. Why did we rationalize? Well, we can estimate the square root of 2. We know the square root of 4 is 2. We know the square root of 1 is 1. So the square root of 2 is somewhere in between there. We know 14 times 14 is 196, so 1.4 times 1.4 would be 1.96. That's really close to 2. So I know that this is really close to 1.4 over 2. So I know that this value here, and equivalently these values here, is really close to 1.4 over 2. So it's really close to 0.7. That's why you rationalize, so you can mentally compute an approximation of the value. And so your teacher's probably going to insist on this version of that these values look like this. If you're taking my class, don't worry, either one's fine. Math Made Simple, Simpson Math.